Swayam Prabha. Digital India. Educated India.
Welcome back, everyone. Today we turn our attention to one of the most fundamental components of financial market, that is called debt markets or bond market. So these markets play a vital role in how governments, corporations, and even individuals they raise funds, manage risk, and plan for their future. And one of the key theme that is used in the debt market is rate of interest. So in order to get a better grip on the concept of rate of interest, so let's begin to explore the four major types of debt instruments commonly found in the bond market. So these are simple loans, fixed payment loans, coupon bonds, and zero coupon or discount bonds. So each of these instruments work differently and carries its own implications for borrowers, lenders, and the economy at large. So let's begin by going through each of these four debt instruments in detail, so that gradually we'll come to know what's meant by interest rate. So eventually we'll define what is interest rate, and while doing so we'll also come to know what is meant by bond and what are the different types of bond and how they have been used in the finance market. So as I mentioned here, there are four major types of debt market instruments. So let's go one by one. So let me begin with the simple loan. So simple loan means simply the loan that we normally take from a bank, for example 1 year, or you lend someone. So in order to get a clear idea of this concept, so let me introduce you another term that is closely related to the debt market, that's called future value or future cash flow. So sometimes we call it for the time being CF. So it means the value of an investment on a future date based on its present value and interest rate. So I just give you a very simple example. For example, you invest $100 today in a bank that guarantees 5% interest per year. So after 1 year, obviously you know that you will have 105, that is the original 100 plus the 5% interest. So the future cash flow here is of 100 1 year from now at a 5% interest rate is 105. So using a simple interest rate formula, we estimated that the future cash flow of 100 at a rate of interest of 5% is going to be 105. So it's a very basic formula that to begin with, so that once we start discussing other debt instruments, so at that time this basic understanding is going to help you a lot. So here the formula, in order to define that the future cash flow, which I mentioned 105, so that is equal to present value. Present value means 100 plus present value times rate of interest. So when you calculate this one, this is actually 100 plus, when you multiply this one, you are going to get $5, and this is 100. So that means you can also calculate this way, that the CF is equal to future cash flow is equal to present value plus 1 plus I. So the 100 investment yields $5, which explain why an interest rate is sometimes called as yield. So here, based on this very simple example, we are going to define rate of interest as the yield, the yield that you are getting for your present investment. So that is the reason sometimes rate of interest is better understood by calling it as yield or yield to maturity. So from this, yield to maturity means, because I said that the 100 when you invest, you are going to get 105. So that means the 100 to be 105. So that means 105, that is the yield to maturity. So that means when you are investing, the interest rate that equates the present value of all future cash flows, including later on we are going to introduce the concept called coupon payments and face value from a bond with its current market price. So YTM is considered the most accurate measure of the return on a bond because it reflects both the interest payments and the capital gains or losses. So simply the example which I mentioned, when you invest 100, this you are going to get in the future 105. That means 105 that you are getting. So out of this, 5 is the yield to maturity. When you convert this one, you are going to get this one is 5%. So in that way, the maturity period is 1 year here. 1 year is the period of maturity. So after the maturity period, you are going to get 105. So that equate the present value 100 equating to the future cash flow, that is 105. That actually equating is by this rate of interest. That is the difference. Moving further, the important distinction, because I mentioned here a few concepts. So the coupon rate means the fixed percentage of face value paid periodically. So if you buy a government bond, so it sometimes is mentioned that the coupon rate is, for example, 8.5 or 8%. So if you buy a 10-year bond from Government of India, so there will be, for example, 8% or 7% coupon payment. So coupon payment will be there. So that one is called the fixed percentage of the face value paid periodically. So then the interest rate is the general term for the cost of borrowing or return on lending. So that the yield to maturity, that is the actual market rate of return considering the bond's current price, not just its coupon. So in essence, the YTM is the internal rate of return for a bond, capturing the total return if held to maturity under current market conditions. So what we have done in the previous slide is calculating 1 year loans. For example, a 1 year bond, what is the return that you are going to get with a 1 year interest rate. But you know that most of the investments are more than 1 year. Suppose you invest $1,000 today in a bank account that offers 4% annual interest rate. So compounded yearly for the next 40 years. You know that when you invest 1,000, next year you are going to get 1,040. But that if you don't withdraw it, then 1,040 is going to be the principal for the next year. So for that also you are going to get 4%. So accordingly, if you calculate, so if manually if you calculate is going to be a Herculean task. So there is a simple formula to calculate this. For here, how much will you have after 40 years if you invest 1,000 today in a bank account that offers 4% annual interest rate, provided that you are not withdrawing your annual rate interest income. In other words, what is the total future cash flow? So the calculation here is, it can be done by 1000 times 1.04 raised to 40 is equal to 4,401. So that means the formula here is that the cash flow for the 40 years period, the cash flow for the 40-year period is equal to present value. Present value is 1,000. 1,000 times 1 plus I is equal to, you already know that the 4%, 0.4 raised to 40. So that means this, if you plug some these numerical values, you are going to get 4,401. So while doing that, we have derived the formula for calculating the future cash flow of this investment. That means if you invest 1,000 today, after 40 years, in order to get that, you are going to do apply this formula, then you are going to get the future cash flow that you are going to get. So the key insight here is that compound interest allows interest to be earned on both the initial principal and the accumulated interest from previous periods, so leading to exponential growth over time. So moving further, measuring the interest rate here. So what you can do here, that actually from here itself you can calculate the I you can calculate from this formula, but just move a little bit further here, that the measuring interest rate, a present value, a dollar received 1 year from now is worth less than a dollar received today. Why? This is the principle that we discussed one of the previous session, that is time has value. So money today can be invested to earn interest and grow over time. So value after 1 year is equal to $1 if you invest is going to be $1 times 1 plus I. So where is the here the simple present value? So if you calculate the present value, in order to calculate the present value from the formula that we discussed 2 slides back, initially we defined CF equal to PV times 1 plus I raised to 1. So now the PV is it can be redefined as PV is equal to CF, the future cash flow, divided by 1 plus I raised to n. So example here was the present value of 250 received in the 5th year if the interest rate is 20%. So you can plug these values in the formula and then you are going to get this is the present value when you are getting an amount 250 after 5th year. So that means 100.5 if you invest today at a rate of interest 20%, in after 5th year you are going to get $250 as the return if the rate of interest is 20%. So here from this let us calculate the yield to maturity on a simple loan. So in order to motivate you, I raise a simple question here. If you lend 1,000 and expect 1,400 in return after 1 year, what is the yield to maturity? So yield to maturity is nothing but a rate of interest. So what I did earlier in the previous slide, first we started with the future cash flow, that the CF, then thereafter we need be using the using the present value, the amount that you are going to invest today plus the rate of interest. Then subsequently move the calculation to the estimation of the present value, provided that you are given when you are given the rate of interest and the future cash flow. So now given this both the framework, now we are going to calculate the rate of interest in a simple loan. So here the present value is equal to 1,000, cash flow is going to be 1,400, and the number of years is equal to 1. So in this, if you plug this value, you are going to get this value, that the I plus 1 plus I raised to 1 equal to the CF divided by, this is the CF divided by PV. So here what we have defined, that 1 plus I raised to 1 is equal to CF divided by PV. So this is going to be 1.4. So that means I here is, the I that you are going to get here is 40%. So to conclude this discussion, this short discussion, for simple loans, the interest rate equals the yield to maturity. So now let's move to another kind of debt instrument. That one is called fixed payment loan. So by the way, here the same way you can calculate it, because here I used only 1 year. So you can calculate for the n number of years you can do. So whichever year you want, you just put that value here, then you will be getting what is the rate of interest. So let's now move to another debt instrument called fixed payment loan. This is nothing but an EMI loan. So when you take a car loan, bike loan, or education loan, so you need to pay an EMI, a monthly payment. So for the time being, let us make it a year annual payment. So a fixed payment loan involves equal payments made over the life of the loan. So here what I mentioned that LV is the loan value. Suppose you have taken an education loan of 10 lakhs. So let that be the loan value. Then the fixed annual payment that you need to make every year. Then the number of years until maturity, maybe you can give it, for example, 10 years, 20 years, and the interest rate that the bank asks pay them. So accordingly, plugging all this value, you are enter the loan amount here, for example 10 lakhs, and every month, for example, you need to pay. So not every month, for the sake of simplicity, we made it a year. Every year you need to pay, for example, 25,000. So then the number of years, it will maybe 20 or 25. So plugging value all this information here, you are going to get what is the rate of interest. So from this you can calculate the rate of interest. So accordingly, you just need to do some manipulation of this framework value. That means you just bring I plus 1, this one on the left hand side, then you can calculate the rate of interest from here. So you can calculate either of these. Suppose you are given only the fixed payment or and rate of interest and the number of years, then you can calculate the loan value, or otherwise whichever information one is missing, so accordingly rearranging the formula, you can get the detailed information. So let's now move to another important debt instrument, that is called bond. Bond is widely, that is one of the most prevalent debt market instrument. Even governments they borrow, large corporations they borrow by issuing bonds. That means a debt instrument. So there are mainly two types of bonds. One is called coupon bond and the other one is called zero coupon bond. So the formal definition for bond is: a bond is a debt instrument in which an investor loans money to an entity, so typically to corporate or government, which borrows the fund for a defined period of time at a variable or fixed interest rate. So when it comes to the suppliers of bonds are those who are borrowing the money. So bonds are used by companies, municipalities, states, and sovereign governments to raise money to finance a variety of projects and activities. So in this case, the supplier who issue bonds, mainly companies, municipalities, states, and sovereign governments, they issue the bond or they supply the bond. Then who demands the bond? Those who demands us, normally who lend money to the government or to the companies, large corporation, they are the demanders of this bond. Also recall, bond is a debt instrument. So who demand this? Demand means who lend to the government, companies, large corporations, etc. So the owners of bonds who buy it from them, they are the debt holders, they are the creditors of the issue. So they own this bond issued by the supplier of the bond. So based on this, let's first define what's meant by coupon bond. So a coupon bond means a bond, it comes with a coupon at every period of time. Normally every 6 months, the bond will be giving you a coupon rate, maybe 10%. Suppose the government issue treasury bill, for example, 10,000. So they will be paying you, for example, 10%. No treasury bill, there is no coupon. For just to make the idea very simple, for a 10-year bond, suppose government is giving you every year 10% coupon rate. That means whoever is holding this coupon, they will be getting 10% coupon or interest income from the government, the supplier of this bond. That is the agreement here. So a coupon is stated as a nominal percentage of the par value, that is the principal amount of the bond. So each coupon is redeemable per period for that percentage. For example, a 10% coupon on a 1,000 par bond, that is the face value, is redeemable each period. So note that an important thing that you need to note here, sometimes people get often confused with the coupon rate with the interest rate. That is actually sometimes people get denote, but actually the coupon rate is sometimes denoted as interest rate, but the actual rate of interest is the yield to maturity. That is the actual market rate of interest. So to get more idea of bonds, I would suggest you visit this website. One is I have given the link for BSE stock market. There actually you can also see in the secondary market not only stocks but also debt market, bond market is also there. And also you go to RBI website, you will get lots of information about bonds, what is meant by bonds, what are the different types of bond, and how RBI on behalf of central government auction bond periodically to raise money for the government. So I'm showing you here screenshot of a coupon bond. So what you can see here is that the face value is 1000 here. That is the face value or par value. So what you can see at the bottom here, this is the coupons. This is, you can see these are the coupons. So that means suppose this coupon is for every 6 months. So that means every 6 months you can redeem each of these coupons. First 6 months you redeem this, another 6 months you redeem this one. That means you just redeem this one with the issuer of the bond. You will be getting the coupon payment. Whoever is holding this bond. Okay, so here what is written here is that the 1000 face value having coupon bond with a 50-year maturity period. So the percentage, the 3.5 percentage is the coupon rate issued on May 1st, 1945. So that means there will be half yearly with the bond, the coupon is paid. You can see that there will be 100 coupons here because 50 year is the maturity period of this bond. So before moving further, let me also explain another kind of bond that is called perpetual bond. Perpetual bond means a perpetual bond is a bond without any maturity date. That means that is issued forever. So they are not redeemable. For in the previous slide, the screenshot I have shown you, that one is for 50 years. That is not a perpetual bond, but the perpetual bond means there is no maturity date at all. So they pay a stream of interest payment, that is the coupon rate. They agree to pay you a coupon rate throughout its lifetime. That means forever until the issuer buys it back. So the issuer has an important point here is that the issuer has the option to buy back the bond after a specified period. So the call option is typically 5 years after the date of issue. So let's now move to the calculation of the price of coupon bond. So the formula here is that the price of a coupon bond is what you are going to get for the coupon. So the price means the present value of the bond. So that means in order to buy a coupon bond, how much you need to pay today. So that is the PV of the bond, that is the price that you need to pay. For example, the principal payment, what you are going to get at the end, that also you need to calculate. So the present value of the bond is the present value of yearly coupon payment plus the present value of principal payment. So you need to take into account the coupon payment as well as the present value of principal payment. That means you need to discount what is the present value of the principal payment. Accordingly, you need to, that will be the market price for a coupon bond. So I have defined here what is P, that is the current price, also called the present value. This one, this is also can be here. The PV of the bond is nothing but the price of the bond. So C means yearly coupon payment, then F is the face value of the bond, then N is the years to maturity. So this is the formula P equal to C1 plus I plus, you can see now that this is the coupon payment stream. This is the pay stream from payment from the coupon payment, and the last component is the present value. This one is the present value of principal payment. So important note here is that the par value of a bond is the amount of money that bond issuers agree to repay to the purchaser at the bond's maturity is also called as the face value. So the face value normally, suppose in the previous example we have seen 1000, it will be printed on the bond itself. That is the one reason we call it as the face value. It's already printed there and clearly say that at the end of the maturity period they will pay you 1000, plus you will be getting periodically the coupon payment. So I am here giving you, to make this idea simple, I am just providing you an illustrative example. So consider a bond with a par value of 1000 set to mature in 3 years. So the bond has a coupon rate of 3.5% and the current market interest rates are 5% with a coupon payment made annually. So normally coupon payment is made every 6 months, but for the time for the sake of simplicity, I have just presented here annually. So what is the present value, that the market price of the bond? What is the price of this bond in other words? So what is the discount rate? So in order to calculate this, we can go ahead like this. The market price of the bond, that the PV of the bond, we already defined PV of the coupon payments plus PV of the principal amount. So we have all this data here. Let's now calculate the present value of the principal repayment at maturity. That is the present value of the principal amount. So that is going to be 1000 that you are going to get after 3 years is going to the present value of 1000 at the rate of interest 5% is going to be 863.84. And then the present value of the annual coupon payment, so that you need to bring the 3 years coupon payment that you are getting. So this is the formula for that. Here the present value of the coupon payment is going to be 95.3. So then you need to add both, then you are going to get the present value, the price of the bond, that the PV of the bond is this. So that means you are going to get 959.14. So that means a bond which has a face value of 1000, that means after 3 years you are going to get 1000 after 3 years, and the coupon rate is 3.5. that means every year you will be getting 3.5% as the coupon rate. That means the 35 you will be getting every year. So in the ongoing market rate of interest is 5%. So in order to get that kind of bond, you need to pay the present value, that 959. So in order to buy, given all this information, to buy this particular bond, you need to pay 959.14. So from this, you can also calculate the discount. This bond is also called as the discount bond, because most bonds, when they're transacted in the market, it will be sold at a discount. So first, let us see what is the discount, then we can calculate the discount rate. So the discount is the difference between the face value minus the present value. So that means this one. So what is the discount rate? So you just plug again, put this one. So this is the discount value is 40.86 divided by 1000. So the discount rate is 4.09%. So let's now move to the fourth instrument, that is called zero coupon bonds. In the zero coupon bond, we don't have this coupon payment. Semi-annually, there is no coupon payment. So a bond may also come with no coupon. So in this case, the bond is known as a zero coupon bond and are typically priced lower than the bonds that with the coupon. So here, this is an example, a zero coupon discount bond. So you can see that this is issued in 1969, October 9, and after 6 months is going to mature, that is 1970. So here the face value is 1 lakh. So then this one will be sold. What is the ongoing market rate of interest? Because there is no coupon here at all. What you are going to get that whoever is buying this one now, after 6 months, this person is going to get $1 lakh. So that means you need to discount it with the current market rate of interest. So that means definitely someone going to buy it. So less than 1 lakh. That is going to be the market price of this one. That you need to discount with the rate of interest. So an example of this one is the treasury bills issued by Government of India. This is a short-term debt instrument. I have mentioned here money market instruments. So presently Government of India issue 3 tenors of treasury bill, one for 91 days, 182 days and 364 days, less than 1 year. So treasury bills are zero coupon securities and pay no interest. Instead, they are issued at a discount and redeemed at the face value at maturity. So here I am giving you an example. From this you can calculate what is the rate of interest. So the return to the investors is the difference between the maturity value or the face value and the issue price. So simply you can calculate here is that the rate of interest is going to be 7.35 from this example. Suppose 91-day treasury bill, the face value is 100, but the selling price today is going to be 98.20. Then the difference is 1.8, and that is the rate of interest. The discount value is going to be the rate of interest here. If there is no coupon payment at all, you can directly equate the discount rate as the interest rate. So I'm giving you a formula here how to calculate the price of a bond is the face value divided by 1 plus I raised to t. T maybe you can accordingly based on the day you can include, or annualize also you can calculate. So what we can see here is that there is an inverse relationship. For example, from this formula itself, what you can see that throughout I have used this approach. The I is the denominator here. For example, when the I increases, what you can see that P is, suppose this I is going to decline, then you can see that P is going to increase. So in the previous session also, here also I have given this example. In all this formula here, for example, the present value here, everywhere the I, the moment we increase I, when the rate of interest decrease, P is going to increase, or otherwise when the rate of interest increase, P is going to decline. So that means there is an inverse relationship between rate of interest and the price of bonds. So simply from this whole discussion, we have found one theoretical relationship that is called inverse relationship between interest rate and bond price. In other words, when the rate of interest increase, bond price will decline, or otherwise when the rate of interest decrease, bond price is going to increase. You just plug some values here, then you will find out empirically this relationship. So what we have done in this lecture is that we discuss what is rate of interest. We have discussed rate of interest as the yield to maturity. So in order to get a better clarity of this idea, we define what are the various debt instruments. We started with a simple loan, then to the fixed payment loan, then we discuss coupon bond, then finally we discuss zero coupon bond. Thank you for watching this session, and see you in the next session. Thank you.